Welcome to The Explainer. Today, we're diving deep into an absolute beast of a challenge, managing modern data centers. We're going to unpack some really fascinating insights directly from Supermicro's SuperCloud Composer documentation to see exactly how industry leaders are completely optimizing their workflows. Let's get right into it. So picture this. You've got 20,000 servers. How do you manage all that without completely losing your mind? That is the core pain point IT architects and DevOps teams are facing every single day. Modern data centers aren't just big, they are wildly complex. You're dealing with tens of thousands of heterogeneous servers across massive global facilities. We're talking different brands, different architectures, different purposes. Trying to keep track of that whole shebang without your operational efficiency tanking, it's a monumental task.
All right, let's start with Section 1, the vendor lock-in problem.
If you've been in this space a while, you know that data centers have historically been plagued by tool sprawl. You buy a new server, you have to learn a whole new proprietary system. It was the old way of doing things, relying on legacy, proprietary IPMI tools. You're dealing with cryptic, non-standardized command sets, getting locked into one vendor's ecosystem, and worse, passing metadata in clear text, which is an absolute nightmare for security. The modern approach, though, relies on open Redfish standards. It's a secure, standardized RESTful API framework built specifically for enterprise scale. And that brings us to Section 2. Enter SuperCloud Composer. This is exactly where Supermicro steps in to fix this industry-wide headache. They basically said, look, administrators shouldn't have to juggle half a dozen totally different tools just to keep the lights on. Enter SuperCloud Composer, or SCC. It's a unified platform. It uses intelligent agents to securely harvest your vital metadata across your entire infrastructure by parsing those standardized Redfish API endpoints. Compute, storage, networking, it doesn't matter. SCC acts as an open distributed management framework to unify the whole operation. And scale is the magic word here. 20,000. SCC uses this highly optimized pod view visualization, which means you can monitor up to 20,000 hosts from a single pane of glass. Think about that for a second. You go from bouncing between a dozen different proprietary apps to managing what is essentially a small city's worth of computing power on one screen. Moving right along to Section 3, Unified Lifecycle Management. Let's look at what this means on the ground. Think about a day in the life of a server, starting with day 0, deep discovery and initial setup. SCC's unified dashboard is all about minimizing those mouse clicks. From your desk, you push firmware updates, access servers via IKVM, perform remote storage erasures, and manage power. You can even trigger UID blinking, flashing that little blue light on a physical server so a tech can actually find it on the floor. It completely eliminates the need to drag a physical crash cart down those freezing cold server aisles. Of course, before you actually execute any of those actions, you need some solid guardrails. SCC handles this using Redfish health rollup states. Those intelligent agents we talked about, they are constantly monitoring your hardware and putting it into one of 3 states: good, warning, or critical. This enforces strict compliance. So, say a server is in a critical state because of a dead memory DIMM, SCC's guardrails will actually block you from pushing a new operating system to it until someone physically fixes that hardware issue. You might be wondering, just how deep does this monitoring go? Honestly, really deep. During initialization, SCC does a massive deep discovery. It natively parses Supermicro's own golden SQs, like their Big Twin servers. But here's where that open Redfish standard shines. It seamlessly parses third-party endpoints too. Dell's iDRAC 9, HPE's ILO 5, SCC looks right into a third-party server and instantly identifies the exact Intel or AMD processor family, the socket count, the thread count, you name it. And yes, this extends right into your advanced accelerators. With AI and machine learning workloads absolutely booming, you need deep GPU telemetry. Take a general-purpose GPU, like the NVIDIA L40S. You can monitor exactly which PCIe slot it's sitting in, its memory usage, power-drawn watts, and track its temperature over time, all right there on your customized dashboard. Okay, the hardware is healthy, discovery is done. Let's jump to Section 4, Fast Deploying Operating Systems. Welcome to day 1 of our server's life. Now, the classic day 1 pain point is slow provisioning. No one wants to deal with clumsy, expensive hardware appliances just to push an OS onto a Blade server. SCC handles this brilliantly with its fast deploy service. It's a clean process. First, you grab a raw golden image snapshot from your storage pool. Second, you inject your vital metadata right into it, like your complex root password. Third, SCC deploys the image by orchestrating an ISCSI boot from SAN over the network. To put that into perspective, the efficiency gains here are wild. Think about a traditional PXE boot process using a standard cobbler service to load something like VMware. That can easily eat up 18 to 20 minutes per server. SEC's fast deploy via boot from SAN, it executes in literally seconds. When you're managing massive enterprise service level agreements, shaving 20 minutes off every single server deployment is a huge operational win. For DevOps teams, this is a real game changer. Deploying an OS in seconds by performing a boot from SAN operation becomes incredibly important for specific use cases. Whether you're pushing a raw Ubuntu 18 image or spinning up Rocky Linux 9.3, DevOps can instantly inject their custom parameters and bring bare metal servers online immediately. And remember, that works even if it's a third-party HPE ProLiant box. Finally, let's look at Section 5, Data Mining for Decisions. So it's day 2. You have 20,000 servers humming along, generating an absolute ocean of metadata. What is the point of collecting all of this? Why data mine? Well, it bridges the gap between the IT rack and the executive boardroom. Use this data for capacity planning so you know exactly when you'll run out of compute power. You use it for tech refresh cycles to spot those older generation processors that are bottlenecking your apps. And for the finance department, this precise hardware data is absolutely critical for calculating capital equipment amortization across fiscal years. And getting that data out is super easy. Administrators can just trigger a dump of all those server component attributes straight into a CSV file. From there, that raw metadata drops perfectly into Excel pivot tables, giving you a comprehensive global view of everything: product families, form factors, CPU socket counts, and exact DIMM memory sizing across all your facilities. Visualizing this information, it takes asset tracking to a whole new level. Let's say your DevOps team is scrambling. They urgently need a server that can handle a massive new AI dataset. With this data filtered out, you can pinpoint the precise rack and pod location of a GPU server that has a massive 512 gigabyte memory footprint, and boom, you migrate your workloads there instantly. We've covered a lot of ground here, right? From the deep discovery of day 0 all the way to extracting business intelligence on day 2. But I want to leave you with a question to really think about. Is your data center infrastructure truly open, or are you locked into yesterday's management silos? Embracing unified, standard-based management isn't just a way to save a few mouse clicks. It's about fundamentally unlocking the agility of your entire enterprise. Thanks so much for joining me on this explainer, and keep exploring.